Hey, what's up, fellas? Doing some testing for Emmanuel today. He has a process furnace that's required to melt down some rock that they use to make paint and cement. I believe he said it's been taking 30 hours and way too much oil. So today we're doing some testing with spray nozzles and oil. This is fresh oil. This is not waste oil. I wanted to test the nozzle before we clog it up because I know how hard it is to use waste oil on these types of nozzles. So I gave it a shot. And within seconds, I got 1,000 PSI hydraulic line whipping me in the side. This is what happens with waste oil, guys. It's a very finicky substance. It must be filtered and filtered and filtered again. And sometimes even after you filter it, somehow something ends up making its way into the system. And it doesn't take much. In this case, it was quite a bit. That appears to be either some vegetation or some Teflon tape that has made its way into the system and clogged the nozzle up before we even had a chance to fire up the burner. This is why I typically don't mess with nozzles when it comes to any type of burner application with waste oil. There's a lot of junk in there, and there's a lot of strange hairy fibers that I've showed you guys in other videos that seems to clog everything up no matter what. So this is the system we got here. This is a leaf blower with a triac, and we've got an atomizer nozzle in place. So we're doing a little test here just to see how this thing runs and look at its different features. I'm going to be testing it on high fire, lean, rich, low fire, all that stuff. So far, it's not that bad to look at. We could do better if we had a jet engine configuration. This is the Godzilla design. The Godzilla design works amazing on compressed air, so I thought I'd try throwing a blower behind it. But there's just something about compressed air that blowers can't do. And this right here kind of shows that. No matter how much air I put into the back of this thing, it just won't do that super lean flame. But nonetheless, I think this here is going to be powerful enough to increase the performance of that furnace. We should be able to melt these stones in a far less time than 30 hours. I've definitely melted some flux materials before, and very quickly, as quick as 15 minutes in some of my high temperature forges and foundries. And I'm hoping that this will do the trick. This right here is a lean flame, high temperature, and it's using a minimal amount of fuel with a lot of air, basically. And this will get this whole combustion chamber red hot. But in practice, we would have this thing covered up with insulation to kind of store that heat. And that smoke you see is from a gasket that I have placed on the back. Add a little bit of waste oil on the back of it during assembly. But so far, I'm pleased with the burner. I just don't have the equipment yet to test those new spray nozzles. This is an air atomized nozzle because I wanted to show you both. I'm testing the combustion chamber on air atomized fuel right now. We are not using the atomized high pressure oil nozzles. This is just a conventional siphon nozzle with a 4mm spud. And it's doing pretty well. Look at the amount of heat flying out of that thing. Those sparks you see are just some fabrication debris and stuff like that, little pieces of metal that get hot and fly out of there, and a little bit of ash from the oil testing. I think this is probably going to be better than a cyclone system because more of the energy is going towards the work rather than creating some cyclone fireball inside of a big old beer keg sized burner, because the amount of power you're wanting would require a pretty good sized cyclone burner. This is a look at the inside. Look at the intensity of that inner cone. It's literally white hot in broad daylight. That's pretty cool. You know it's bright when you can't look at it with your naked eye without it like burning your eye like the sun. So I was kind of impressed with that. I think the spray nozzle is going to be way more finicky and more problematic out in the bush. But that's what you wanted. You wanted a system without air, so I'm just kind of showing you with air for the simple fact that I clogged up the nozzle in 10 seconds, and I'm not going to bother with that spray nozzle anymore. It's not suitable for what we're doing. So that's why I purchased some 80-degree cones and some 60-degree spray cone nozzles, because I think that'd be more appropriate for the combustion chamber that we got. So it wasn't a total failure. I feel like a jet engine, like combustion liner design, would be better, and we may still be going that route. This might not be the final sauce that we put on this pizza here. We'll figure it out. I'm just kind of checking out different flame settings for now. So far, it's you'd probably hitting 2200 to 2400 degrees with this burner. It's not gonna do much hotter than that, but that's what we got. All right, Emmanuel, so the nozzles showed up. The problem is they thought it'd be a good idea to make this a 9/16 by 24 threads per inch thread. Unfortunately, that's a very exotic thread, so now I either got to order an adapter or a tap. So I'm going to do that, and then we'll be down the road here. I wasn't expecting them to send such an oddball thread like that. This really should have just been like a 1/2 inch or 3/8. But there you have it. So we are getting, we're getting there. I just can't do nothing with these just yet. So once I do this and we get the jet engine design going, we will be able to run the waste oil at a lot higher temperatures